Hello everyone, welcome to my YouTube channel Physics with Sagar. Today we are going to continue our mathematical physics previous year question solution video. In the part 1, as you have seen that we solved some questions related to previous year questions of KSET examination, that was of year 2020, 2021 and 2024. There we did some questions of matrices and some questions of complex algebra and calculus. Today we are going to continue further the questions. There will be few questions of complex, then vector analysis, and further we will move ahead likewise. So before going to today's questions, I want to rectify a mistake that I did in previous video, that I told when a matrix is applied on a function, it gives back the function with some constant, then that matrix is known as eigenfunction, but I was wrong there. When a matrix is applied to a or operated on a function and it gives back the function with some constant, then that function on which the matrices was operated is known as eigenfunction. Like in previous video, the example was, if A is a matrix and it is operated on X and it gives lambda times X, then A is eigenfunction, which is wrong. X is the eigenfunction. So please rectify that correction, and I'm really sorry about the mistake. So without wasting any more time, let's jump into today's video. This is the part 2 of previous year questions of KSET examination. I hope you are liking the video. If you have some suggestion, then please do let me know in the comment section. So in previous video, I hope we left this question on this question. So moving ahead, let's see what is the next question. Now see, this is the question which says that what is the sum of residues of the function fz if f of z is, f of z is e to the power z, in denominator it is z square plus a square. Wait, let me correct the length of this. The thickness is too much. Okay. So if this is the function, what is the sum of residues of at all its poles? So how many poles are there? Let's see. How do you find the poles? We just put the denominator to 0, that is z square plus a square equals to 0. So from here we get z square equals to minus a square. So z will be your plus minus iota a. So there are two poles for this equation, that is z equals to iota a and z equals to minus iota a. We have to calculate the residues at these points, at these poles. In last class I told you that if your function, complex function f of z is in this form, phi of z by psi of z, then to calculate the residue at z equals to z naught, what you can do is limit z tends to z naught, this phi of z upon psi dash of z. Okay, so using this property only we will try to find the poles, residues. So sum of the answer will be sum of residue at iota a and minus iota a. So first we have to calculate residue at z equals to iota a. So limit z tends to iota a. What is your phi of z here? E to the power z upon the differentiation of this psi of z, which is z square plus a square. Okay, so z square plus a square, a is a constant, so z square differentiation will be 2z. Now if you put iota a here, what will we get? E to the power iota a upon 2 iota a. Okay, this is what we get from here. Next, let us find residue at z equals to minus iota a. So here limit z tends to minus iota a e to the power z upon same differentiation, you will get 2z. So you will get here e to the power minus iota a divided by minus 2 iota a. Now you have to find the sum. How to find the sum? So the sum will be your answer. The sum of residues will be residue at z equals to iota a plus residue at z equals to minus iota a. It is e to the power iota a upon 2 iota a plus, but here you have a minus, so minus e to the power minus iota a divided by 2 iota a. Now you can check the options. Here the answer is not in this form, so we have to convert this further. So you can see the denominator is same, so you can write it as iota a e to the power iota a minus e to the power minus iota a divided by 2 iota a. Now if you know, sine theta can be written as e to the power iota theta minus e to the power minus iota theta upon 2 iota, and cos theta can be written as e to the power iota theta plus e to the power minus iota theta upon 2i. So from here you can see that this part, I will change the color, you can see that e to the power iota a minus e to the power minus iota a upon 2 iota, this part can be written as e to the power, sine a. Okay, so you can write this as sine a. So this part will be sine a upon a. So you have to check where is your option. Sine a by a will be your answer. You can see option A, it is sine a by a. So for answer for this question will be sine a by a. I hope this is clear. We'll move to the next question now. Next question is the value of the contour integral. If it is not visible, I will write it down. The value of the contour integral C r cross dr mod. What is the value of this contour integral? If your circle is of unit radius, that means your radius is 1 and centered at origin, that means if this is your xy plane, then at 0, 0 this contour is made of radius r equals to 1. R equals to 1. Now whenever you do a cross product of two vectors, you get the area. Okay, and they are asking that area's integration in whole contour. So first you should know, since it is a circle as mentioned, so circle's position vector in what you have to write in polar coordinate. So it will be r cos theta I cap plus r sin theta j cap. But you can see that r is 1, so r vector will be what? Cos theta I cap plus sin theta j cap. You got r vector. What about dr? You just differentiate this r with respect to theta. So what will you get? Cos theta will be minus sin theta I cap plus cos theta. Sin theta differentiation is cos theta j cap. So from here dr vector will be what? Minus sin theta I cap plus cos theta j cap into d theta. Okay, so wait a minute. I'll move it to the right. Okay, so if you solve further, you just have to first take the cross product. So r cross dr, what will be this? How do you take a cross product? I cap, iota, I cap, j cap and k cap. What are the components of r vector? In I cap it is cos theta, here it is sin theta, and k is 0. Here it is minus sin theta, it is cos theta here, and it is 0. So r cross dr will be what? If I take for I cap, see, for I cap it will be sin theta into 0, 0, and cos theta into 0, 0. So I cap component will not come. For minus j cap, so cos theta into 0, 0, minus sin theta into 0, 0. So only component which will come for is for k cap. So for k cap, what it is there? So k cap, this row and column subtracted, so row and column is not included, then cos square theta minus sin square theta. So it will be cos square theta plus sin square theta. Sorry, sin square theta. I hope this is understood. It's cos square theta minus sin square theta. Okay, so you get cos square theta plus sin square theta, which is nothing but just k cap, because cos square theta plus sin square theta is 1. Okay, so you got it like this, but again d theta was there, so you have to write d theta also. Okay, so the integral c k cap d theta, and they have asked you the mod, just the magnitude. If you just take the magnitude of this, it will be integration d theta. Now you know, in spherical coordinates, r limit is from 0 to infinity, theta limit is from 0 to 2 pi, sorry, theta is 0 to, but in polar coordinates, theta is from 0 to 2 pi. Okay, so you get the solution as integration 0 to 2 pi d theta. So you will get the answer as 2 pi. So the option number 3, this is the correct answer. Okay, so moving ahead, let's move to vector algebra and calculus. So everyone knows what is vector. Vector is just a quantity which has both magnitude and direction. Okay, so for now let's keep it simple only and understand the vector is any vector quantity is a quantity which has both magnitude and direction. Actually it also satisfies a condition that the vector transforms according to displacement, but that is not important now. We have to discuss main things like what is a dot product. Everyone has studied dot product, cross product since childhood, so I don't think there will be any difficulty in it. So a dot b, if two vectors a and b are there, then their dot product will be magnitude of a, magnitude of b into cos theta. Okay, so you can see that if we have to check whether two vectors are perpendicular to each other or not, then what you have to do? Perpendicular means they have 90 degree in between them. So if any two vectors dot product comes to be 0, then the vectors are perpendicular. You can say that they are perpendicular. Okay, if I have to calculate the area between two vectors, if they are originating from the same point, I will use cross product. Okay, so cross product gives you the area between the two vectors if they are originating from the same point. So a cross b is what? Magnitude of a into magnitude of b sin theta. Okay, so from here you can calculate the area of the vectors, area of the shape made by these two cross products, two vectors originating from the same point. How do you calculate the cross product? A vector cross B vector will be what? I, J, K, A1, A2, A3, B1, B2, B3. What is area A1, A2, A3 here? It is A1 I cap, A2 J cap plus A3 K cap. B is what? A1, sorry, not A1, sorry, it is B1 I cap, B2 J cap plus B3 K cap. Okay, so this is how you calculate the cross product. Now this was okay for a two vector problem. If I have three vectors, so there are two things you should know, that is scalar triple product. Okay, scalar triple product is what? If I have three vectors A, B, C, then A dot B cross C is your scalar triple product. What is the value of this? It is box of ABC. How to calculate a box of ABC? It is determinant of A1, A2, A3, B1, B2, B3, C1, C2 and C3. This is how you calculate a scalar triple product, and they are cyclic in order. So like ABC will be equals to BCA. That means how will you write BCA? It will be B dot C cross A. You will get the same value for this. Similarly, you will get same value for C dot A cross B. Okay, so it will be C B, sorry, not B, A, C A B. Okay, so for all this you will get the same value. So this is scalar triple product. What is the application of scalar triple product? You can find out what first is application or use. What do we get from here? One is volume of a parallelepiped. Volume of a parallelepiped. Second, volume of a tetrahedron. I hope you all know what is a parallelepiped and what is a tetrahedron. Parallelepiped is any 3D rectangular structure, a rectangular kind of structure where one of the angle is not 90 degree. That means something like this. So these kind of structures are your parallelepiped. What is a tetrahedron? You have seen tent. So tent is a tetrahedron. Okay, and to calculate this, one thing very important is that all the three vectors should originate from same point. That means vector A, vector B and vector C. They should originate from same point. Okay, so this is the use of scalar triple product. Here you can see the usage of what? Cross product. The area of triangle, you can calculate half into A cross B. Okay, so this is the formula for this area of a triangle. From cross product you can calculate this also. Okay, then moving ahead, what is vector triple product? Okay, so vector triple product, that means A cross B cross C. It is, I use a like technique to you remember this formula, which is back minus cab. Back minus cab. Cab is a like driving vehicle transportation. Okay, so that cab and back. So you can write it as b into okay, b into a dot c. This is back minus cab, c into a dot b. So this is the formula for vector triple product. Okay. In previous slide I told you the application, but the formula for this is box of ABC. You just calculate this determinant, you will get the volume of parallelepiped. And for tetrahedron, you just calculate 1 by 6 into box of ABC. You will get volume of tetrahedron. Okay. And the next important thing in vector algebra, and this is, you should know what is gradient, what is divergence, and what is curl. Okay. So divergence is grade of f. This operator is known as grade or nebula operator. Okay. The value of gradient is del f by del x I cap, del f by del y j cap, plus del f by del z k cap, where your nebula operator is del by del x I cap, del by del y j cap, plus del by del z k cap. So this is the value of your nebula operator, or which is known as gradient also. Okay, I hope you all have studied this part before also, so there will not be any major issue in it. Okay, so next thing is, what is the physical meaning of gradient? Gradients tells you the maximum rate of change in particular direction, directional derivative. Okay, so you can see it is a derivative with direction. Okay, so directional derivative, in which direction the rate of change of a function is maximum. Okay, so in many questions there will be, what will be the maximum rate of change for the given function. There will be a function given and they will ask what will be the maximum rate of change for this. So for that question you have to find out the gradient of that function. Okay, so this is gradient. Next, what is divergence? So the formula for divergence, that is del by del x ax plus del by del y ay plus del by del z az. So this will tell you how much the field is diverging, how much vector field is diverging from a point, from a given point, how much scattering is there in that field, vector field. From that point it is going, how much it is diverging. Okay, so it will tell you the divergence of a vector field. What is ax, ay, az here? The given vector field A will be ax I cap plus ay j cap plus az k cap. So see, you have this operator, nebula operator dot a vector. So when you will do dot product with this, you will get I cap component with this. So you will get del by del x ax plus del ay by del y plus del az by del z. Okay, so this will be divergence. From a given point, this vector field will give you how much it is diverging. Okay, next is curl. Curl is represented like this. Okay, how to calculate curl? It will be I cap, j cap, k cap, del by del x, del by del y, del by del z, ax, ay, az. So solving this determinant will get the curl of the vector field. Okay, curl of vector field tell you how much rotation is there in a given function. If for any function curl comes out to be 0, then this field, vector field, is known as irrotational or curlless field. Okay, so this is how you calculate gradient, divergence and curl. Gradient is maximum rate of change of the your field, scalar field in particular direction, and then divergence is how much a vector field is diverging from a given point, and curl will give you the amount of rotation that vector field is having. Okay, so we should move to questions, I hope, from here. Let's see. Some questions will be very basic, which we study from 12th, related to vectors. So see, what is this? Identify the vector that is perpendicular to both this vector field and this. Okay, so you have to calculate a vector which is perpendicular to these two vectors. You have been given two vectors, vector A, I cap plus 2j cap minus 3k cap, and vector B is given as minus I cap plus j cap minus 2k cap. Now they are asking what will be your C vector which is perpendicular to both A and B. So to calculate the third this, you can do one thing, that you just do the cross product of these two things. Cross product of A vector and B vector, you will get a C vector which is perpendicular to both. How? See, what is A cross, what is A cross B? A cross B is what? Magnitude of A into magnitude of B into sine theta. What will be sine theta if these two are perpendicular? It will be 90 degree. Okay, so magnitude of A into magnitude of B. Okay, so solving this, you will get a cross product somehow. Okay, so you will get a vector which will be perpendicular to these two. So you will get a vector C. So let's see what will be vector C. A cross B is I cap, j cap, k cap, and components of this 1, 2, minus 3, and this one minus 1, 1 and minus 2. So solve this, you will get a vector C which is perpendicular to A and B. So I cap, what you will get? Minus 4 to minus 3. So it will be minus 7. No, not minus 7. Minus 4 into minus, minus 7 into minus 3. So this will be plus 3. Okay. Minus j cap into, what will be this? Yeah, 4, sorry, not 7, 4. Then this will be minus 2 minus 3 plus k cap 1 plus 2. Okay, so this will be minus 4 plus 3, that means minus I cap. This will be minus 5. Okay, minus 5 into minus, it will be plus 5 j cap and plus 3 k cap. So this is the third vector C which is perpendicular to both A and B. So what will be that? Option C is correct. So this is one of the method of solving this question. But you have one more method. See, they are telling that identify the vector that is perpendicular to both this and this. So any one of this will be perpendicular to this vector. Okay, perpendicular means a dot b will be equals to 0. So you just do the cross product, I into I, what you will get, and then you can find out like this also. If you don't remember this actual method how to calculate the third vector, if you don't remember this, you can do that also. Dot product of any two vectors will be 0 if the vectors are perpendicular to each other. So you can do it by options. Just take dot product of any vector among this and you can solve that. Okay, go ahead. Should I show? See, I'll take this vector. This is minus I cap plus j cap plus 2 k cap, and dot product with this minus I cap plus 5 j cap plus 3 k cap. What you will get? I cap minus minus, it will be plus 1. This will be plus 5, and this will be, wait, this is minus 2 k cap. J cap minus 2 k cap, so it will be minus 6. So you will get 0. So like this also you can do. This is a very simple thing if your calculation is fast. Okay, so next question is, you have to find out a vector dot gradient of phi. You have been given phi also, vector a also. Your vector a is what? And they have given the point at 1 comma 1. So your vector a is what? 2y I cap minus x square y j cap, and gradient of phi. See, what was gradient of phi formula? It was del by del x of phi I cap plus del phi by del y j cap plus del phi by del z k cap. What will be this? Del phi by del x I cap. So differentiating this with respect to x, you will get 4xy I cap. Okay, plus differentiating this with respect to y, you will get 2x square j cap plus differentiating this with respect to y, so that will be 0 k cap. Now you have to do dot product a vector dot gradient of phi. So what you will get? Dot product of this 2y I cap minus x square y j cap. Okay, and you have to do it at point 1 comma 1. So I cap you will get 4xy into 2y, and then next minus 2x square into x square y. So what will be this? 8xy square minus 2x to the power 4 y. At point 1 comma 1 you will get, this will be 1, 8 minus 2, it will be 6. So option number C is correct. Next question. Okay, so before moving to this question, I have to tell you about Dirac delta function. So surely in every exam there is one question from Dirac delta function. Okay, so you can see Dirac delta function. What is the Dirac delta function? Or Dirac delta function. So Dirac delta function is a function which has a unique property. Okay, if I have this axis, okay, at x equals to 0, it will have a infinitesimally thin and infinitely long peak. Okay, so it will be like this something. Not always at x equals to 0, but at some point it will be like this. This will be a Dirac delta function. It will be thinner than this in 1D. Mostly the question are asked from 1D only, so I will explain only 1D Dirac delta function. So at particular point it will have a peak which is infinitesimally thin. Infinitesimally thin means similarly thin. That means it is very less in area. Thickness will be very small and infinitely long. That means it will be very long. Okay. So this is the Dirac delta function. How you write it mathematically? It will be 0 at x equals to 0, and it will be, sorry, it will be not x equals to, it will be infinity at x equals to 0. As you can see, it is a long peak. So at x equals to 0 it will be infinity and 0 everywhere. Everywhere means wherever x is not equal to 0 it will be 0. And it has a very important property that integration, that means area under this loop, area under Dirac delta function will always be unity. Okay, by integration you get area under the function, so area under the function will be unity, so it is so thin. Okay, so there are some important properties on which the question is mostly asked. There are mainly 4 properties. Okay, you have to write it down very nicely. Okay, just write it down in one page. So properties are properties of Dirac delta function. The first property is, if x equals to, sorry, kx Dirac delta function of kx, k is any arbitrary constant, so it will be mod of k into delta x. So for example, if I have Dirac delta function of minus x, so what will be that? It will be mod of minus 1 into Dirac delta function of x, so it will be again delta of x. Okay, I have to tell you one more thing, that if it is not at x equals to 0, if it is at some point, this is x equals to 0, it is at point something x equals to a. Okay, so then how do you write the Dirac delta function? Okay, so Dirac delta function is written like this, x minus a. So a is the argument at which point the peak is there. Okay, so minus a. If x plus a is given, that means the peak will be at minus a. Okay, that much you have to understand. Okay, so we'll continue with properties. So this is the first property. Mostly this is not used, or in calculation it might be used, but based on this the question will not be there obviously. Next question is integration b to c f of x. F of x can be any function they will give, and not d, Dirac delta function of x minus a dx. What will be the value of this integration? So value of this integration will be, it will be f of a. Okay, if a belongs to b minus, sorry, b comma c. If the point lies between b and c, if your integration is like this, 2 to 4, and your a is 3, then the value will be f of a. Just put the value of a in this function, you will get the value of this integral. If it is not like this, that a does not belongs to b comma c, then the value of this integration will be 0. Moving ahead, next property is b to c f of x, and you are given some derivative of delta function. Okay, so the value will be minus 1 to the power n f to the power n a. That means you have to differentiate this function with respect to x, how many times? The nth derivative, whatever derivative the question will be given. So if a belongs to b comma c, if not belongs to b comma c, then it will be 0. Okay, next, fourth property, it is Dirac delta function of a function. g of x. G of x is some other function and Dirac delta function of that is asked. Then it will be summation I 1, it will be g of x, not g, and Dirac delta function of x minus alpha I. I will tell you what is this alpha I, divided by g dash of alpha I. Alpha I are roots of g of x. That means you just put g of x equals to 0, you will get the roots, and your g dash of alpha I is what? It is dgx upon dx at alpha I, different roots. N is what? Number of roots. Okay, alpha I are roots. Okay, so these are the properties of Dirac delta function. Okay, so let us move to the questions. Where is this question? This was one question, that value of the integral. They have asked the value of integral from minus infinity to infinity d by dx of Dirac delta function into e to the power iota kx dx. So you can see this property number 3. Okay, f of x is there, differentiation of this is there, Dirac delta function is there. So differentiation of Dirac delta function of order 1 means first order derivative, and function is f of x is here what? E to the power iota kx. So for this type of thing, what you do? Minus infinity to infinity. Let us recall the property f of x, Dirac delta function of x minus a dx. You will get the value as minus 1 to the power n, Dirac delta function of this f dash of fn of a. Okay, since there is first order derivative of this, so we have to derivate this function once and just put the value of a. What is a here in this question? A is, you can write this Dirac delta function as x minus 0. So a is 0. Now continue this solution. What will be the solution? Minus 1 to the power 1, since n is 1 here. Okay, and then f dash of f1 of first order derivative of this e to the power iota kx into iota k, and you have to put the value of x equals to a as x equals to a. So you will get minus 1 into e to the power, sorry, a is 0 na, here a is 0, so iota k into 0 into iota k. So e to the power 0 will be 1, so you will get minus 1 into iota k. So your value will be iota minus iota k. So option number D is correct. Okay, so this is how you solve the question to Dirac delta function. Next, so this is a little tricky question, not tricky actually, but you have to apply a formula. The total surface area of 3-dimensional parallelepiped. Okay, a 3D parallelepiped is what? Any structure which is like this. Okay, okay, so this is a parallelepiped. They have given us 3 vectors, vector a, vector b, vector a, vector b, vector c. So you have to calculate origin from the origin. Okay, it is originating from origin. They have given us 3 vectors. So how do you calculate the area of this parallelepiped? Now there is no direct formula for this. So to calculate the area between any 2 vectors, what you have to do? You have to just cross product. So if I get the area of this by doing a cross c, then I will multiply it by 2. so to get this area also. So I will get these two areas. Then I will do cross product of A cross B. I will get the area of this part. Then similarly into 2 I will get the area of this. And again B cross C I will get the area of the back part, and multiplying by 2 I will get the front part. So the total area of this parallel pipe will be 2 into magnitude of A cross B, okay, plus like this A cross C or C cross A, anything, it's okay. And then B cross C and C cross A. Okay, so doing this you will get the area. If you calculate this, should I calculate this or not? So area of A cross C, I will just write it here only. No. Let us calculate A cross C now. I will put it aside for a moment. Okay, so A cross C, A cross B, what is this? I, J, K. What is the value of A? I plus J, so 1 1 0. And what is your B? It is JK, so it is 0 1 1. So what will be the value? I cap you will get 1 minus 0, 1 minus 0, minus J cap, what you will get? 0 minus 0, so 0, plus K cap, what will be this? 1 minus 0, so 1. It is I cap plus J cap. Okay, am I correct? Sorry, K cap will also be 0. I cap will be 1, J cap will be 1, J minus J cap minus J cap, you will get 1 minus 0, and this will be wait J cap you will get, okay, K cap also you will get, wait a minute, I will do it again. J cap will be, listen to this, 1 you will get 1, plus K cap you will get 1. So this is I cap minus J cap plus K cap, and magnitude of this will be root 3. How do you calculate the magnitude? A square plus B square plus C square, whatever you will get, it will be the magnitude. So magnitude of this, so area of this A cross B you got, this is the magnitude actually, okay, so this you got root 3. Next term, B cross C. So what will be B cross C? I will do it here only. So B cross C, what is B here? J plus K, so 0 1 1, K plus I, so it will be 1 0 1. What you will get here? I cap is 1 minus J cap into 0 minus 1 plus K cap into 0 minus 1. So this will be I cap plus j cap minus k cap. So again the magnitude will be equals to root 3. So next term also magnitude is root 3 plus c cross a. Let's find c cross a now. So c cross a. What is c? K plus I cap. So 1 0 1. What is I cap? Sorry, a. It is I cap plus j cap. So you will get 1 1 0. So the value will be iota into 0 minus 1 minus j cap. It will be 0 minus 1 plus k cap. You will get 1 minus 0. So this is your minus iota minus I cap plus j cap plus k cap. Again its magnitude will be root 3. So what is this? 2 into 3 root 3. So this is 6 root 3. Answer is 6 root 3. Option C. Okay. So next question. Now see. They have asked the greatest rate of increase of this function phi equals to x y z square at point 0 comma 1 comma 2. So you have to take gradient, the maximum rate of change in a particular direction. Okay. So grade phi, what you will get? Del by del x I cap del of phi del phi by del y cap plus del phi by del z k cap. What is this? Del phi by del x. Differentiating this with respect to x, you will get y z square plus y z square I cap. With respect to y, you will get x z square j cap plus what is this? With respect to z, you will get 2xyz k cap. And this is asked at point what? 0 comma 1 comma 2. So substitute these values. Wherever x is there, that term will go to 0. Okay. So this will be 0. This term will also be 0, since if you put x equals to 0. So these two gone. Only this term is left. Y equals to 1 and z equals to 2. So this will be 4 I cap 2 square and y is 1. So 4 I cap. So this is what? This is the answer. It is 4. Okay. You got the answer as 4 I cap. Okay. Let's move to the next question. So here we are finished with what? Equations. Questions related to vector algebra. Now next move it to differential equation. If you move to differential equation, I'll not tell you how to solve the questions related to first order differential equation and second order, because all those things are variable separable. In first order differential equation, then that linear differential equation where you find out if and y. Okay, integrating factor is what? E to the power p dx, where linear differential equation is written as dy by dx plus p of x y equals to q of x. This is the form of linear differential equation. So you find out integrating factor and then write solution as, you write the solution as y into integrating factor equals to integration q into integrating factor dx plus c. So from here you calculate y and then you get the answer. So these are the two famous things. Then in second order differential equation we will discuss the question. From there you will get to know. And then some special functions are there that we will discuss later. First, let us see what will be the two independent solution of this following differential equation. Okay, so there are two methods. One is by which most of the people will do, and one is a trick. Okay, so for a second order differential equation, there will be two solutions. Okay, so to check whether the solutions are linearly independent or dependent, we write a Wronskian. Okay, Wronskian is a what determinant. If how do you write this? If there are two solutions, y1 and y2, so you write the Wronskian like this: y1, y2, and y1 dash, y2 dash. If this is equal to 0, then the solutions are linearly dependent. Okay, if it is not equals to 0, that means the value is something else, then it is linearly dependent. Similarly, you can do this for vectors also. If two vectors are given, okay, and they ask two vectors are given, then you just put the components ix, y, z and calculate the Wronskian for that. Then you will get whether it is linearly dependent or not. Okay, and the other method is write the auxiliary equation of this. See, for writing auxiliary equation, you should know that dy dx is written as d. Okay, so first you write this equation as d by dx is d, then d square by dx square will be what? D square. So this equation will be d square y plus 3d y 3dy plus 2y equals to 0. So you just remove d and write it, you can take y common, so it will be d square plus 3d plus 2 into y equals to 0. So you can write this equation as m square plus 3m plus 2 equals to 0. So solving this equation, okay, so you can write it as m square plus 2m plus 3m 2m plus m plus 2 equals to 0. So I hope this equation will be solved from here, or you can use Sridharacharya formula. So m will be what? Minus b. Sorry, why minus b? Can take m plus 2 common and m multiply plus 1 into m plus 2 equals to 0. So your roots will be m equals to minus 1 and minus 2. So your solution will be e to the power minus x, e to the power minus 2x. Okay, so option E is correct here. These are the two independent solutions, or else you can just write this Wronskian. Okay, so to write Wronskian, but for Wronskian you have to do option wise. Okay, so let's see how to calculate that. So Wronskian for option A, see, it will be e to the power minus x, e to the power minus 2x, and differentiation of this will be minus e to the power minus x. This will be minus 2 e to the power minus 2x. You just have to see whether this is getting 0 or not. So this will be what? Minus 2 into e to the power minus 2x minus x. So it will be minus 3x. See, multiplication 2x into e to the power minus x and minus e to the power minus x into e to the power minus 2x. What you will get? Minus 2 minus 2 e to the power minus 3x minus e to the plus e to the power minus 3x. So you will get as minus e to the power minus 3x. It is not equals to 0. So these two solutions are linearly independent. Okay, this is dependent when it is equals to 0, not equals to 0, that means the solutions are independent. So the two independent solutions of the following differential equation are this. So this is a small solution, can do it. You can see for other it will come out to be 0 only. Okay, so let's move to the next question. So this is legendary polynomial question. So first, before going to this, I have to discuss there are totally 4 type of special functions. Legendary differential equation is a special function. So special function are of 4 types. So special functions are of types. First one is legendary, or some people spell it pronounce it as legenders. Okay, so legendary differential equation. Second is Basel's differential equation. Third one is Hermite polynomial or Hermite differential equation, and fourth one is Laguerre differential equation. So you do these two by yourself, just go through internet, you will get those things. Now we will discuss first legendary polynomial, okay, or legendary differential equation. Legendary differential equation, what is the legendary differential equation? It is minus 1 minus x square d square y by dx square minus 2x dy by dx plus n into n plus 1 y equals to 0. So this is the differential equation. You have to do some things for Hermite and Laguerre. What you have to do? You have to see what is the differential equation for this. Then next, what is the solution of this, which is known as Rodrigues formula. What is Rodrigues formula for this? Okay, so Rodrigues formula is Pnx. Okay, this is equals to 1 upon 2 to the power n factorial dn by dxn x square minus 1 to the power n. So this, by doing this, you will get the values of p0x, pnx, sorry, p1x, like this. Okay, I am really sorry for the background noise. This is the first thing you have to do, that is find what is the differential equation for Hermite and Laguerre. I will tell you for legendary and Bessel. Then what is Rodrigues formula. Then you have to see what is the generating function. I have some guests at home, so please excuse me. Generating functions. What is the generating function? So generating function for legendary polynomial is 1 minus 2xt plus t square to the power minus 1 by 2. It is equals to summation pnx t to the power n equals to 0 to infinity. And the fourth thing you have to see for a differential equation is special function is what is the orthogonality condition. So orthogonality condition for legendary polynomial is what? It is integration minus 1 to 1 pnx into pmx dx equals to 2 upon 2n plus 1 delta nm. What is delta nm? Delta nm is Kronecker, sorry for the spelling, Kronecker delta function. Okay, so the value of delta nm is equals to 1 when n equals to m, and when it is not equal, that means when n is not equals to m, then it is 0. So for n equals to m, you will get 2 upon 2n plus 1. Okay, so these are the values you should know. Okay, just write it down, pause the video and write it down. I will erase this and tell you, will solve this question. Special function is a topic where you have to remember a lot of things in this mathematical physics. Rest all are okay, but this part is very tricky because you have to remember a lot of formulas and differential equations. Okay, this question is related to associated Laguerre polynomial, which is very useful in spherical coordinates in quantum mechanics. So Laguerre associated legendary polynomial value is, it is Pnmx. So the value for this is 1 minus x square to the power mod of m by 2 d mod of m by d x to the power mod of m. That means if minus 2 is there, then also you have to use 2 only. That means they both have the same value, that's why, and it is Pnx. So using this formula you have to solve this question. They have given you that P2x, okay, P2x is 3x square minus 1 by 2, and they have asked you P22x, which is associated legendary polynomial. So this is a direct question. If you know this formula, it is a direct question. So P22x will be what? Minus 1, why I am telling minus 1 first? 1 minus x square to the power mod m by 2. Already it is 2, again divided by 2 is 2 by 2 is 1, and differentiation of second order derivative you have to do, that is 3x square minus 1 by 2. So it will be 1 minus x square, and this 2 is constant, so I will take it out, and 2 times derivative of this. First time you will get, doing one time derivative you will get 6x minus 0. Okay, and again if you will derive 1 minus x square by 2 into 6, so this 3 you will get as 3 into 1 minus x square. Where is the answer? 3 into 1 minus x square, option A. So this question is next. So this is a tough question according if you see the standard of KSET questions, this question is considered tough because this is the question asked in 2023 net paper, 2024 net paper. Okay, in June the net paper was done, June CSIR net, June 2024 the question was asked, and then in November in KSET 2024 they just copy pasted the question with some slight modification. Actually you have orthogonality condition from minus 1 to 1, Pnx, Pmx dx as 2 upon 2n plus 1 delta nm. But here they have asked what is the value of 2 to 4 Pnx. They have given this, they have changed the orthogonality condition to this, dx equals to delta mn, and they have asked what will be p0 of x and p1 of x. P1 of x, what will be p0 of x and p1 of x if orthogonality condition is this, not this. Okay, so we have to change something. So if you can see, what is p0 of x? P0 of x is 1 for this orthogonality condition. Okay, but I will do some corrections. I will remove this. Now this is our required thing. So if this is the orthogonality condition, then p0x is 1, p1x is x, and p2x is 3x square minus 1 by 2, like this. These values are there. So if this this is the orthogonality condition, p0 of x will also be some constant. Okay, and p1 of x, according to you, your options, you can see that it is something 3 minus x, 3 plus x, some sign is there. Okay, so you can take any constant a and into 3 minus x. If you have taken sign and any sign wrong, then substituting in this integral, you will get the correct answer. So first let us calculate this p0 of x. Okay, if you put p0 of x in this, what you will get? 2 to 4 p0 of x into p0 of x dx equals to 1. So solving this, what will be that? 2 to 4 into c square dx equals to 1. C square is just a constant, and integration this will be x limit 2 to 4 equals to 1. What will be this? This will be c square, 4 minus 2 is 2 equals to 1. So from here you can see that c is 1 by root 2. So wherever option, that means your p0 of x was what? C. So p0 of x for this kind of what orthogonality condition will be 1 by root 2. So let's see in option where is that answer. In only one option it is 1 by 2, rest everywhere it is 1 by root 2. So your answer is either 1, 3 or 4. So now we have to do it for p1x. So if you do it for p1x, what we will get? I'll do it here only. So 2 to 4 a square into 3 minus x square dx equals to 1. A square is constant, it will come outside, and integration of 2 to 4 3 minus x square dx to 1. Let us take 3 minus x as t. So what you will get? Minus dt. Dt equals to what? Minus dx. Okay, and your limit, see, when x equals to 2, at x equals to 2, t will be 1, and at x equals to 4, your t will be minus 1. Okay, so now the integration will change to a square into, at 2 it will be 1, this will be 1 minus 1, this is t square, and dt will be dx will be minus dt, so minus dt. If I take minus inside this, so you will get a square minus 1 to 1 t square dt. T square is a even function, so you can write it as, it is just integration now, 2a square 0 to 1 t square dt. Next it will be 2a square t cube by 3 0 to 1. So you will get 2a square by 3, which is equals to 1. This integration is equals to 1. Okay, so you will get a as 3 by root 2. So your p1x will be root 3 by 2, 3 minus x. So option number 3 by root 2 under root 3 by 2, 3 minus x. So option number 3 is correct. So here we finish our questions. There are some questions for practice. You can just see that. You can pause and solve this question. I will give a quick solution for this in this video only. You just go through it. Pause and solve this question. Try it by yourself. This topic I have told you yesterday. Okay. So in this question you can see that eigenvalue of a 5 cross 5 matrix B have given as lambda I as 2, 1, 0, minus 1 and 2, minus 2. That yesterday I told for n cross n matrix there will be n eigenvalues. Okay, so they have given 5 cross 5 matrix, so they have 5 eigenvalues. So they have asked the determinant of e to the power b. So I have told you, if the eigenvalues of b are this, then f of b will be f of lambda I. Okay, here your f of b is e to the power b, so lambda I here will be e to the power lambda I. Okay, so your eigenvalues for e to the power b matrix, okay, will be e to the power 2, e to the power 1, e to the power 0, e to the power minus 1, e to the power minus 2. Okay, so this will be e to the power 2, e comma 1, e to the power minus 1, e to the power minus 2. So these are the eigenvalues for your e to the power b. Now they have asked the determinant of this. So determinant of e to the power b will be what? It will be product of eigenvalues. Yesterday we have done this. Okay. Sum of eigenvalue is trace of A, trace of the matrix. Product of eigenvalue is determinant of this. So you know the eigenvalues. So e to the power 2 into e to the power 1 into 1 into e to the power minus 1 into the power minus 2. So this both cancels out by each other and you get answer as 1. Okay, next, this today we have done for f of x delta. Sorry, you first pause the question and solve this. You will get minus 1 to the power n f n a if a belongs to b comma c. Okay, since x is 0 here in this question, so you can see that it will be differentiation of sin x will be my differentiation will be cos x. Okay, and then the value of this is cos 0 at x equals to 0, so will be cos 0, which is 1. So option A is correct. Next question, I hope this is visible. How to zoom this? Okay, I have this. Wait. So this is the question here. You can see that the solution of the differential equation. This is the first order differential equation, dy by dx as minus y cube upon x to the power 4. So variable separable, easy question. So y cube dy by y cube minus of y cube equals to 1 upon x to the power 4 dx. So integration both side with, again you will get solution as, you can see minus outside, again to the power y to the power minus 3 plus 1 upon minus 2. Okay, so it will be minus minus cancels out, so this will be 1 upon, wait, I will write it, this minus minus is cancelled out. So this will be x to the power 4 x to the power 3 upon minus 3 plus c. So this will be 1 upon y square minus 1 upon 3x square plus c. Okay, so your answer will be what? 1 upon 3x square plus 1 upon y square equals to constant. So in which option it is there? Nowhere. I have missed 2. It is 2 here. Okay. Wait. Here we can solve this. Here only we can solve this question. Wait. See, this was minus on 2 minus 2. This got here it was minus, not minus, x to the power minus 3 upon minus 3 plus c. Okay, so what you can write it on the left hand side is, just send this to left hand side. What you will get? X will be x cube by 2 plus y square by 3 equals to c. So I did it ulta. x cube by 2 ulta hoga. Wait, what silly mistake I am doing, man. You can see, you just send this here on right hand side. It will be y square by 3 so you will get 3 by y square plus 2 by y cube equals to c. It is just a simplification, you just go through it. And then next question, you have this: which of the following matrices is Hermitian? Hermitian you have to do A dagger equals to A. So you do this by yourself and do let me know which is the correct answer in the option. Yesterday I have proved that option C is Hermitian. Okay, so go in last video and just check it out. So the volume of parallelepiped with edges this. They have given you 3 vectors A, B, C, and they have asked volume of parallelepiped, which is box of ABC. So you just have to solve this determinant. What is vector A? It is I plus j. So 1, 1, 0. What is vector B? J plus k. So it will be 0, 1, 1. What is vector C? It is k plus I. So it will be 1, 0, 1. So if you solve this determinant, what you will get? The answer 1 minus 1 into minus 1 plus 0. So this will be 2. Option D will be the correct answer. Which differential equation has singularities x equals to 1, minus 1 and infinity? I forgot to tell that for legendary differential equation, the singularity points are at 1, minus 1 and infinity. So option A is correct answer here. Option A is the correct answer. Okay, so here we finish the questions related to matrices or matrix and determinant, then complex, then we have done vectors and differential equation. So this was the part 2 of your mathematical physics previous year questions. I hope you understood everything. This video also took a long time to finish because there were many questions, and I hope you are understanding everything. If there is any doubt, please comment, and please like and share with your friends who are preparing for KSET examination, and also please subscribe. That is a source of motivation for me to make the videos. I wish you very luck for your preparation. If you have any doubt, I have given my number in description box. You can just contact me anytime. And if there is any correction in this video or any feedback that you want to give me for betterment of these videos, please do let me know. Thank you so much, and please like, share and subscribe.